What is Tezos like, or what is a blockchain in general? Tezos is a distributed ledger. It's a sort of piece of software that is run by several people across the globe. And the idea is that we want to record transactions that are performed by users. So imagine there are a lot of users that they want to perform transactions, like I want to send money or Tez to somebody else. I will perform a transaction. And then the blockchain is basically the data structure, or is a place where all these transactions are recorded and they get verified and finalized. In a sense. Another thing that I forgot to say, this is very important because they usually ask me when I interview people, like, oh, what is the main strength of Tezos? And probably that's governance. So yeah, I think the best feature of Tezos is probably governance on chain. What does that mean? It means that Tezos is a self-amending ledger, meaning that developer teams can, or anybody really, that's the beauty of it, anybody can post a proposal for a new protocol upgrade. So what does that mean? So you can make your own changes to the protocol of the blockchain. And what is the protocol? The protocol is basically the set of rules that govern how the state of the blockchain changes when a new block comes in and gets applied by the nodes. Anybody can propose changes. And again, basically they take the code of the protocol, they take a they take a fingerprint out of it, which is again a cryptographic hash, and they can post an operation on the blockchain itself. So this operation will be included in some block that say, hey, I have this proposal. Like, this is my protocol proposal. And in this case, like, we start the first of 5 stages of the governance mechanism, provided that we were not one, there was not some proposal already in action. And but let's say that there were no proposals so far, like somebody posts a new proposal, like a new protocol hash that needs to be applied in the next protocol upgrade. Okay, first stage, like there may be multiple proposals. It lasts around 2 weeks, and basically bakers. So bakers are those that participate in the process of securing the network by validating and assigning new blocks or proposing new blocks as well. Bakers can vote for the proposal, and a quorum of 5% of the amount of TES available in the so of the total amount of TES. So basically, bakers can vote for the proposal for a proposal, or they can inject a new one, and the voting power that they have is directly proportionate to the amount that they have staked plus the delegation state. The delegation stake. I'm going to talk a bit more about that later, but yes, this has to do with another feature of Tezos, which is liquid proof of stake. So, but yeah, basically, bakers can inject a proposal, bakers can vote, and their voting power is directly proportional to the amount of stake that they have, so the total value locked for baking purposes, and also plus the amount of stake delegated by other people to the baker, so they can vote. And 5% of the total stake, so needs to vote for a proposal for it to go to the next phase, which is the exploration phase, I think. No, I think it has a different name, but I don't remember all the names. But it's basically in the second phase, like the proposal that received at least 5% of the votes in the first stage and received the most votes among all possible proposals need to be voted for. I think around 50% of the stake needs to vote for this proposal to go forward. In reality, it's never 50%, like it's dynamic, it changes, there is a formula online. But the idea, more or less, is 50 of more 50, a little bit more than 50. And of the 50% need to vote, need to express a vote. And of that 50%, a supermajority of 80% needs to say yes, we want to go forward. After which this phase lasts for another 2 weeks of time. Actually, it really depends from, it's usually expressed in blocks, the length, because how many blocks the blockchain needs to apply. But after Mumbai, a block takes around 15 seconds minimum, at least 15 seconds to be applied, but to be produced. but then it could be that some baker is offline, so they want to be able to propose a block, and then it might take a little bit more. But let's say if all the blocks take 15 seconds in a best case scenario, like I would say this process lasts around 2 weeks. If the proposal gets enough votes, we get to a quiescent period of 2 weeks, which in where people can test for the new upgrade. Like there are going to be test nets where people can experiment with the protocol. They can try to see what changes to their own products are needed to support the new protocol. And eventually, after these 2 weeks are over, there is going to be a final vote. Again, 50% or a little bit more of the stake is needed as a quorum, 80% of a supermajority of votes that should vote yes. Then if this final vote goes forward, like the protocol proposal is voted, then there is a final 2 weeks period, which is basically adoption, which means that the new protocol is going to be, the protocol of the blockchain is going to be upgraded, and people just need to make sure that they upgrade the software, they are ready to support the new version, because it's going to happen. So, and then after these 2 weeks, the blockchain, provided that all the bakers have updated their software, then the blockchain will just switch to the new version. And we are seeing when it was the time of Tech, I think it took a little bit of time to see the blockchain going again, to perform the upgrade. That's because some bakers forgot to upgrade the software to the version that was required to run the Ithaca protocol. But Jakarta had some other issues, but it also took around 20 or 30 minutes. But for the last proposals like Kathmandu, Lim, and Mumbai, the upgrade of the blockchain took 30 seconds. And that was flawless. It was really nice to see it's nothing happened, and then the blockchain was using a new protocol. And there are big changes that get introduced, like smart rollups were an extremely big change that were introduced with Mumbai. So why do we have this own governance mechanism? It's because we want to avoid hard forks, which means people just will start their own version of their own variant of the blockchain, which is what happens with other blockchain. For example, sometimes hard forks are needed in other blockchains to upgrade. So Ethereum did that, with the merge, it was a hard fork basically, and it was a little bit more complicated. But let's say that then there is also the problem that if you don't seek consensus via a governance mechanism, for example, there are people that decided to say, after the merge, we don't want to migrate to proof of stake for Ethereum. We want to stay on proof of work because we spent a lot of money in infrastructure for mining. So we are going to run our own version of Ethereum, which still has proof of work. So Tezos governance mechanism tries to avoid the hard forks because people did not agree with the proposed changes. Same as Ethereum, Tezos is a smart contract platform, which means that originally when blockchains were invented, with Bitcoin, they only had a store, they were only used to transfer Bitcoin, which means that the only operations that they were allowed were, I want to transfer a certain sum from one account or from one account to many others. Tezos, it's different since it's a smart contract platform, which means that we have two different kinds of accounts in Tezos. So one is implicit accounts, which are basically originated by users like me and other people, and they have no code associated. Then there are also these other accounts which are called originated account, and there's some code associated to them, which basically means that when you perform a transfer to these accounts, that code will be executed. And what does it mean? It means that if a transfer to that account gets into a block, when the nodes of the blockchain will download the block and they will need to compute the new state of the database resulting from the ledger, then what will happen is that they will need to execute this code. Now, this code is defined in a particular language called Michelson. The Michelson virtual machine is basically a typed stack-based virtual machine, which means that you always can put, you have a stack, so of values that you can place, and basically you can push values in the stack. You can pop them, you can also retrieve some information deeper in the stack. The main idea is that you can execute code, you can specify code associated with your account, and users can perform transfer operations to this account to execute the code. And there are many applications that you can define with smart contracts. For example, FA tokens on Tezos, like basically it's just you can define your own token, and the smart contract will just basically define the rules how you can swap tokens from Tez to Tez or between different pairs of tokens. Like there are constant product market makers or constant function market makers. Like this is more into DeFi. I'm not really an expert in that, but the idea is that there are so many things that you can do using smart contracts. Oh, and of course there are non-fungible tokens, like which are used quite a lot on Tezos. Okay, so what else? Like this is, I will say that actually Tezos since the latest upgrade, Mumbai, it goes a little bit ahead of other blockchains because yes, Ethereum has smart contracts, like many other platforms have smart contracts. The focus of Tezos right now is on scalability. So with the latest upgrade, Mumbai, we actually brought smart rollups on mainnet. And what does it mean? Like, as I mentioned, like with smart contracts, everybody, you can define code that is executed by issuing transfer operations to the smart contract address. But the main problem is that, if you remember what I said before, is that everybody, when they need to apply the new state of the blockchain, and by applying the block where there is a transfer to the smart contract, they need to execute the code. Everybody, like all the people participating in the blockchain that want to apply this block, they need to execute the code. And from the point of view of computational resources, this is kind of a waste, and it's definitely not scalable. So smart rollups are Tezos' answer to this problem. Here I really need to digress a bit because what are the main points of the blockchain? So this is called the blockchain trilemma. If you look in Twitter and other places, also in academic literature, I think. So the blockchain trilemma says that ideally you would like to have a decentralized network which is secure and which scales. Now, the blockchain trilemma says that you can have at most 2 out of the 3. And Tezos' answers to that is actually smart rollups because they try to achieve decentralization, scalability, and security at the same time. So the idea with smart rollups is that we try to bring the computation off-chain. So nodes that participate in the network, that apply blocks, they don't need to compute the state of a smart rollup in this case. Like smart rollups are different from smart contracts, but they don't need to compute the state of a smart rollup anymore. Instead, there will be dedicated infrastructure, like called the rollup nodes, that will actually have access to the code of the smart rollup and will execute them. Like they will download the Tezos blocks still. They will still apply the operations that there is a special rollup inbox in the block, like that all the rollups will see, and they will try to apply the operations from. Then what happens is that the smart rollup, like in a different infrastructure, like a piece of infrastructure called the rollup node, which anybody can run. They can run this rollup node. They will connect to a particular smart rollup, which is identified by the smart rollup address. And they can execute message transfer operations or operations like from blocks by looking at the smart rollup inbox. And once every 20 blocks, I think it is, or every time they compute 20 blocks worth of messages, they will post a result of the computation to the blockchain, so to the layer 1. What does that mean? Is that now we have a problem because yes, the computation happens off-chain, but you don't have security anymore, in the sense that they could lie. So, especially because they don't post the whole state of the computation, they just post a fingerprint of the state of the computation with some metadata, but they could lie. And so Tezos uses, for smart rollups, we use a mechanism called fraud proofs, which means that basically if somebody decides that wants to make a commitment to the state of the rollup by running the rollup node and posting the state of the computation every 30 blocks or so, 20 or 30, I don't remember, but they can do so, but they need to stake, they need to freeze, they need to lock a value of 10,000 tests. And everybody can do that, which means now that everybody can check what is the state for a given rollup, and post what is the result of their computation. And I mean, smart rollups, the execution is deterministic. So if nobody's lying, then the result should be the same. They should get to the same result. But if somebody's lying, then they will get different results. This will be recorded on the blockchain. And then something called the refutation games, which is probably the most complicated variant of a binary search, is happens where basically in this game, like the two stakers that stake some amount of money, they try to play against each other to say, okay, we did not agree on this set of the computation. So what was the result of the computation halfway? And they say, oh, my result of the computation was this one. And the other one says, oh, my result of the computation was the same one. So we agreed up to halfway. So probably the point of divergence where we don't agree must be later on. And you keep going in this way until you find a single atomic step of computation where the divergence occurs. So you agree on what was the state before the atomic computation. You don't agree what was the state after the atomic computation. And the protocol of the Tezos blockchain can verify which one is the correct step. And in this way, like we say that the stakers had to commit to an amount of 10,000 Tez. The one that is found to lose and have lied is slashed. So 5,000 of these Tez gets burned forever. And other 5,000, like they get to the person, to the account or to the staker that challenged them. Okay, this is like what smart rollups do.